Hi guys, and welcome back to another lesson in Algebra 1. Today's lesson is Unit 3, Lesson 8, and we are going to be looking at discrete and continuous functions, but it's going to be word problems. We're going to be looking at some real-world scenarios of how a discrete or continuous function might work. So in this lesson, you will make sure that you know how to identify domain and range of a word problem. Remember, domain is your x-axis values, and range is your vertical axis values. Now, the deal is when it is a word problem, you're going to have to decide, is it something that's a domain or is it something that's a range? So that's one of the challenges with these word problems. So let's see, what is it that we're going to talk about? Okay, so how would we solve these? Well, step one, what we're going to do is you got to decide if the word problem describes a discrete or continuous function. So remember, discrete is going to be like dots on a graph, okay? That would be discrete. It's certain pockets of information. Continuous means that we could draw it like a line or we could draw a curve. So continuous, you're going to have where you can have partial values. So let's see what we need to write down here for discrete is, remember this is points on a graph. And you will write the domain and range like this. So you're going to write domain and range in this kind of format where you are doing it with your fancy schmancy little curly cues there. So say for an example, -1, 0, 3. You would write it like that. This is different from a continuous function where it is a line or curve. And so you will write the domain and range with your greater than or less than or equal signs. So for example, we could have this one where we write, like, say, -3 is less than or equal to x, which is less than 4. Okay, that could be an example. So you can see the differences in how we would write those. Okay, versus this. This is why it's important to decide if it is a discrete or continuous, because you write the answer differently, but also it just has different meanings. So once you're done deciding what type function it is, if it's discrete or continuous, we are going to do, you got to decide what is your input variable, which is your domain, and what is your output variable, which is range. So remember, input, domain, and independent variables all mean the same thing. And so that is going to be like whatever goes on your X. And then remember, output, range, and dependent variable mean the same thing. And that's what's going to go on your Y. And so when you are reading these, you've got to decide which way it's going to be. Are we talking about like your domain being the independent variable that goes on the X? Or is it going to be, let's do this one, range dependent on the Y? All right, so let's write down this next part. So a tip is that you may need to make a data table, and you will definitely be doing some calculations. But the data table is going to help you to be organized. We want to be organized with this. Okay, so let's look at these two situations down here and let's figure out, first off, if they're discrete or continuous. So this problem here, we have Leo's buying trail mix. He can buy up to 8 pounds, and trail mix costs $5 per pound. So the first thing I want you to think of is, can I buy a partial pound of trail mix? Like, can I buy 0.1 pounds or 2.2 pounds? And the answer is yes. It would be like going to the grocery store and buying bananas and it's by weight. You can buy, 1.5 pounds of bananas. Because we can do this, because we can buy, we can buy partial amounts. This is going to mean it is continuous. Okay, and because it's continuous, we know that we're going to end up writing our domain and range like this right here, where it's got the inequalities in it. So, but first we got to figure out what numbers are we even going to put in here in our inequalities, because it's not going to be the 8 and the 5 particularly. We've got to figure out more. So when we are thinking of continuous, we need to think about where we're starting and where we're ending, okay? And so that's going to give us our whole range, because when you look at this, it's like there's a starting point and an end point. We've got to figure out what those are. And then there are two different values here, and we've got to think about what those mean. So we can buy, we can buy pounds, and then there's going to be cost, right? Like the cost per pound, it's $5 per pound. So, which is going to be which? Well, my my number of pounds, and I didn't leave myself enough room here, that's actually going to be my X value, okay? Because when you go to the store and you're trying to buy something, you're deciding how many pounds you're going to buy. And then the cost is going to depend on how many pounds you buy. And that's going to be your Y, okay? So you make the decision on pounds, and then the cost is what happens based on that. So, for our start, we're going to think about what the lowest is. What's the lowest number of pounds we can buy? And, and it says, up to 8 pounds. So we know that the lowest that we can buy is 0. And it is $5 per pound. Well, 0 times $5 is going to be 0. So we're going to start at 0, 0. 0 pounds is $0. Well, we can buy up to 8 pounds. And it is, $5 a pound. So 8 times 5 is 40. Okay. So now we actually have our domain and range, and we are ready to write that into, the information down here. So let's see, the first question was, is it discrete or continuous? Well, it's continuous, okay, because it's a range. We can buy, 0.12 pounds if we wanted to. Our input is going to be number of pounds. And then the output is going to be the cost, the dollars. And so my domain, when I go to write this, let me just kind of, I'll go color code it, see if this helps out any. I never know if my color coding really helps or not. So my domain, I'm going to be like, okay, we're going to make that yellow. It starts here and it ends here. Okay, it starts at 0 pounds and it goes up to 8 pounds. So I'm going to write my low, which is 0, and my high, which is 8. My domain is my X value, so it goes in the middle. It can be equal or greater than 0, and it can go up to and including 8. Okay, so this inequality is saying that we can buy 0 and we can buy up to 8, including 8, and all values in between. All right, now my range is going to be this y part. Okay, so it's starting here, that's my beginning, and it ends here. Okay, so if it starts at 0, we can write down 0, and the highest it can be is 40. This is my y value. I'm going to put that y in the middle. It can be equal or greater than 0, and it can go up to and include 40. Okay. Alrighty, if I'm going too fast, just pause it. Let's look at a different example. So think about how, like if we're buying trail mix, we can buy partial amounts, okay? And that makes it be a continuous function. Well, look at this and see how this is different. This is going to be a soccer coach will bring between 9 and 12 players to a tournament, and each player needs 3 water bottles, okay? And so ask yourself, can you have partial players? Can we have, 2.7 players? And the answer is no. Okay. And so because we cannot have partial players, that makes this a discrete function. And so I am going to go down here and I'm going to highlight discrete. That's the kind of function that it's going to be. Okay. When we have a discrete function, it's going to look like this. We're going to write the answer in this kind of format. We got to list out all the possible values for both the domain and the range. Okay, and for us to know all those possible values, we're going to have to do a little bit of math. Okay, so I can see that I'm going to have between 9 and 14 players. So let me go ahead and make my data table. Oops. If I don't just accidentally highlight when I don't mean to, once a class, it's just not a class, right? Okay, so we got our number of players here. This is my X value. Okay. My number of players, I can have 9, I can have 10, 11, 12, 13, and 14. Those are all my possible choices based on this phrase right here, between 9 and 14 players. Those are all my possible choices. Okay. Now, I'm going to do some scratch work. So my scratch work we'll put here. And what we're doing with our scratch work is every player is going to have 3 water bottles. So I am going to take, that number and multiply by 3. And then that's going to give me my Y. Okay. So my Y is going to be, total number of water bottles. And the reason that players is my X and water is my Y is the number of players determines the amount of water bottles. The number of water bottles doesn't determine the number of players. Like we're going to bring as many water bottles as we have players, right? We're not going to just set out 6 water bottles and be like, yeah, that's all the players we can take to this game. That's not how that works. That's why the X is our players, because that's like the starting point to this. Okay, so I'm going to do my math here real fast. I've got 9 times 3, and that is going to give me 27 water bottles. I have 10 times 3, and that's going to give me 30 water bottles. 11 times 3, that's going to give me 33 water bottles. 12 times 3, that's going to give me 36. And you probably are noticing it's going up by 3 every time, which makes a lot of sense because each player gets 3 water bottles. So every time we go up a player, it goes up by 3. Let's see, 13 times 3 is going to give me 39. And then you might predict this one is 42. We can just go ahead and write 14 times 3, and that's 42. All right, so now that we figured out all of this, we can go fill out this some more. Our input values, that's going to be our domain, and that's the number of players. Again, why did we say that was our input? It's because the number of players determines the number of water bottles. It doesn't work the other way. The number of water bottles doesn't determine the players. Okay, so we got that. We're going to write down all the possible values here. So we've got 9, 10, 11, 12, 13, 14. So let's write that out. So we're going to do, we got to write down number of players. I got ahead of myself here. And then my domain, I'm just going to list it out. I've got 9, 10, 11, 12, 13, and 14. So we listed it out all nice and organized. And then range, that's the other one. So my range was the number of water bottles. That was my Y value. That's my output. Okay. So my output, number of water bottles. And we can see that we've got 27, 30, 33, 36, 39, and if you can't write your curly braces, well, that's okay. I can't really write them well either. They get a little goofy looking. So this offers you a very clear example of the difference between what a real life continuous function looks like and what a real life discrete function. The discrete, we cannot have partial numbers. It would not make sense. We can't have partial numbers of people. But this, we can have partial numbers of pounds. The partial numbers are going to be continuous. The discrete is the absolute, like we can't break it up. It's just little points of data. And so I hope that helps, guys. Until next time, bye.